Yeah.
Good evening.
Good evening, ma'am.
Yeah. Hello. Able to hear me?
Yes, ma'am.
Yeah. Okay. So now previous session I explained like different types of VLSI, EDA, and how to make microcontroller video already done. And EDA software also I explained. Okay. So few student already did with the analog circuit. Now you have to do with the digital. Okay. Digital like a gate. Okay. And gate or gate and all. So first of all, like few theory part I want to explain. See, like binary numbers, digital system use binary number 0 and 1 to represent and process information. I think I explained this one, but I want to tell you these things. Let me multiplexers and this one, duplex, half, half duplex, full duplex. I want to start this. Maybe what is the introduction to the digital logic design, like a combinational logic? So circuits whose output depends only on this current input. Why I want to explain this one? Because here, whenever you can draw the design, there you should need 8 seconds. So adder, multiplexer, and decoder. So actually, whenever you can draw the combinational logic design. So combinational logic design means just a minute. I want to open that thing. Actually, combinational में क्या होता है? There are the logic gates, arithmetic circuit, and duplex is there. So here already I written adder, multiplexer, and decoder. So I don't know you have the knowledge of multiplexer, adder, and decoder. Logic gates, you know. See, listen now carefully. Whenever this question it will be there, you need to draw the combinational logic gates. So what we have to do, you should know the relevant the adder, relevant the multiplexer and decoder. If you know the decoder, encoder should be there. If you know the multiplexer, half duplex, full duplex is there. If you know the adder, subtractor should be there. Okay, so there is the logic gates, means combinational logic means logic gates are there, adder and subtractor are there. So and even multiplexer. So logic gates के अंदर क्या आता है? What are the combinational logic circuits means all types of gate. Anyone ask this question, what are the combinational logic? So there are the logic gates and inside the logic gate all types of gate and or not, NAND, NOR, XOR and XNOR. Okay. Then arithmetic circuit. Combination logic, first logic gate, then arithmetic circuits. And arithmetic circuits, what exactly it will be perform? It will perform adder and subtractor and multiplexer. So adder and subtractor में क्या रहता है? In that the adder, there are the half adder and full adder. Maybe you learn like a sum and carry. Okay, carry जो आप लेते हो A dash and B dash like this. So that is called the half adder, full adder, and then your subtractor actually it will be subtract any binary number from the another binary number. That is the logic. Multiplexer means mux. Okay, MUX. Generally, it will call the mux. So you can select any one output signal, sorry, input signal, and you can forward to the selected input signal output. So what exactly here? कैसे मैं बताऊँ? You know like a log to log in log जहाँ पे रहता है to okay 4 to 1 mux. How many lines you can select like a 4 to 1 mux? You can uses the 2 lines. Okay, select 2 line. Demultiplexers में क्या होता है? Demux में demux means सी सिंपल थिंग मैं बताती हूँ. मल्टीप्लेक्सर इज लाइक अ n to 1 मल्टीप्लेक्सर means and demultiplex means 1 to n demultiplexer. Now let me add the video better. Encoder means what exactly? Do you know, like a convert 2 raised to the power n inputs, then n is considered like a binary output and all. Guys, reply. आपको पता है या नहीं? Do you have this knowledge or not? Because what will happen wherever you can draw this circuit, so you should know what is the multiplexer, encoder, decoder, comparator. Comparator means what exactly? ऑपरेशनल एम्पलीफायर पता है वो, यू नो द ऑपरेशनल एम्पलीफायर, ऑपैम जिसे हम ऑपैम बोलते हैं. व्हाट एग्जैक्टली ऑपैम इज डूइंग? ऑपैम इज डूइंग एडिंग, सब्सट्रैक्शन, मल्टीप्लिकेशन, डिवीजन. ओके, कन्वर्टर आई टू वी, वी टू आई मीन्स करंट टू वोल्टेज, वोल्टेज टू करंट. सो these types of question generally ask the company, and the company name is, I am telling you, Thermo Fisher company. Thermo Fisher company, they will ask these types of question. What they are doing, they are sharing their screen, okay, and there actually what it's there, they can show all those amplifier relevant. Now see, this is the amplifier I told you, okay. So this is the amplifier is there. Inside one IC is there. Okay, so here it will connect to the all of pull-up resistor. Okay, whenever you can connect any microcontroller IC. Microcontroller IC, you know, there are the minimum 48 pins are there. Okay, these pins are the 48. Here, this one, like any operational amplifier is there, only 8 pin. Okay, if you can like Darlington capacitors, Darlington diodes are there, otherwise MOSFETs are there. There are the counting for the double, like a 16. Okay, see, if you already learn is fine. If not, so just let me know. Okay, so in that scenario, what will happen? You should not connect directly. So in between pull-up resistor are there. And what they are doing now, companies, they are sharing their screen and they will ask you, this is the operational amplifier. Now inside, एक second, I'll just write clearly. Okay, they will add here one value. Okay, this is the inverting. So just here 2 ohms is there. Here you can give the input signal. Input signal may be 12 volt. Here you are inverting. Okay, means non-inverting. This is the inverting. This is the non-inverting. Here you know one current is flowing. This is the RF. This is the RF signal, this feedback resistor. Okay, here this is the output, and this output here, now what is the value? If here like a positive is there, you will get the negative answers from over here. But you need to calculate, okay? They will ask like here current flow, okay? Means see IR na, so IV. Sorry, I current is there, so here I1, I2, whatever. Okay, so current is flowing, so you need to calculate. So they will share their screen. Turn on the light, Vajra. Fast. लाइट ऑन करो. हाँ ये okay. So write down the company name, Thermo Fisher. Generally ask this types of question. There is the favorite questions for the amplifier and the comparator. So comparator means what exactly? Compare the two devices. Okay. So comparator means same like this device, operational amplifier. It is the two signal. So they will compare this signal is greater or this signal is greater. Whatever signal you can apply it over here. Correct. So these types of questions they are asking, I'm telling you the company name and everything because few more students are there. They are, I'm just after interview, na, they are explaining me exactly what they are asking and all like this. Okay. So this is the there. Now pull-up resistor means what exactly? There are the lot of resistors are there. Okay. They need to connect it to the any the header file and all. Header component. Here you can connect your IC, otherwise anything using the jumper wire. Here are the holes are there for the header, and you miss this one for transfer the supply to the any other of the sensor. I told you VLSI student they need to learn internally of the SOC, internally or the chip. Okay, but external like robotics and IoT student, they will check this one. Robotics student generally check the sensor, IoT student generally check with the cloud, and embedded system, they will draw the design exactly. Got it? So these things are there. So everything is included means like your VLSI. So look at now. So adder, multiplexer and decoder are there. So comparator means it will the compare like a, if you can compare like a 4-bit comparator compares the two 4-bit numbers and provide the output for the equally. Like it is the equal to, greater than, less than, whatever. Comparator means it do the comparison. Okay, नाम में ही वो लिखा हुआ है. Okay. So whenever you can draw the combinational circuit, okay, whenever we will start the learning design, in that design process for the combinational circuit, you should know the specifications of these, whatever you have to draw the circuit, then truth table. Truth table में वही A dot B, like A multiply by B, A plus B, like this. Boolean expressions means what exactly? Like whatever the truth table, it will come, the answer, output. Okay. And simplifications में क्या आएगा, like you know the K map पता होगा ना, so like a K map, it will, how many the number of gates are there, you need to write over here. Okay, so if I can tell, just design a 2-to-1 multiplexer means mux, how you can do, just a minute, I drink water. So if I can explain the example, otherwise you can write an example like designing a 2-to-1 multiplexer. So what are the specifications for that? You have to draw the 2-to-1 mux, select any two inputs, like just imagine A and B. Okay, and you can just add whatever, like multiplications, divisions and all. And you can now calculate that the Boolean expression. Maybe it's complete, it's already completed in your college or not. Otherwise, I want to explain. If anyone can tell you, just calculate the Boolean, how you can do. If not, so let me know. I will add the PPT. Otherwise, you can write the notes. Okay. So now here, then now this sequential logic में क्या होता है exactly, what exactly in the sequential logic? Definition: circuits whose output depends on the current input and the previous states, like a history. Example: flip flop, counters and shift register. So what is the flip flop now, and what is the counter? What are the shift register? Don't know. Just a minute, I want to show you one design, you can check it there. Here in this design, there are the full duplex mode is there, half duplex mode is there, and everything. Okay. Video, see, guys, what you have to do, either you can write the notes, otherwise, let me know. If you don't know, I will add in the PPT, few videos. Okay. Like a video link. What should I do? ये मेरे लिए hectic है. Means I need to cut all, because one video is the 6 GB, 7 GB. I need to cut in this like 1 GB or these. How much it will? 25 MB only for the WhatsApp. Okay, 1 GB I can adjust because in this YouTube video. Okay, fine. So what you want to do? Can I add in this PPT this type of video, or you can note down? Reply, guys. What I am telling you, like this. What is the flip flop? How that the 001 binary will be move? Okay, semiconductor knowledge. So that is you need to write, or I need to do. Means I can add it in this PPT. What happened? You can able to speak. You have the access. Add in PPT only. Okay. So I need to cut actually. Last time student they can note it. Okay, because session are more, here less. Okay, no worries dear. I'll add. Okay. So now just watch this one.
It full duplex communications.
This is the
Explain
full
both of
duplex.
them
Okay,
in a
communication.
very
Transmitter and
interesting
receiver.
way. The SPI
हाँ, ये
frequencies
example के साथ देखो.
as well. If you don't know what synchronous
See,
and
एक second
asynchronous
ना. PPT I can share right now only. I don't have any issue. But actually na, I need to add few topics I told you. Okay, that's why. That is also fine. If you want, I can share right now. Okay, I don't have any issue. But what I am thinking na, it will be confusion. So either you can read that one and again I will add and then again I will send. Okay, that is also fine. No worries. If you want to read, I will share. Share it, okay, before 10 minutes. And then again, but I need to add like videos and everything. Okay, this Saturday and Sunday I'll do. Actually, I have also continuous session, so the PPT already ready. But like the course timing is less, so I need to add actually. That is the issues. Otherwise, no.
Communications protocol is then you can watch a video. I have explained both of them in a very interesting way. The SPI communications is a full duplex communications protocol having
SPI communications means full duplex. If you can ask anyone what is the full duplex means, SPI communications you can tell. See that guys, one it's connect to the others. Okay, like here actually lot of technology and like a few more terminology are there. So you need to adding that one. Then only you can understand.
a master and slave
Master and slave flip flop.
configurations.
Okay, huh.
Well, what happens with full duplex communications? In this mode, two devices who are talking to each other can transmit and receive data at the same time. So, SPI communications doesn't really on just one data line. When two devices are communicating using SPI protocol, one out of them is master and second is the slave. A master can be connected to multiple slaves, and there are four dedicated connections lines which are necessary for SPI communications. At the master side there is the MOSI, that is master side. Then comes the MISO, that is the mastering slave out clock signals. And finally there is a chip select line. As per the name, MOSI means the master sends data to the slave and slave receives that data on the MISO line. And slave sends the data and master receives.
So here you can understand how that the binary yesterday I explained in the session, na, but practical I didn't start. So how that the binary data it's transferred. Okay, like this is your microcontroller. If you can connect any other IC, so how that the microcontroller data will transfer.
It. The clock in the communications is very important for synchronizations. Master initiates the clock signals and all slaves receives are the same data as per clock signal. And finally comes the chip select line. This select line is dedicated for each slave. If there are three slaves to a master, then master will have to pull out three chip select lines and connect these select lines to each slave one by one. So, if you see, this is the limitations of SPI communications. The number of GPIOs restrict the maximum number of slaves. This chip selected is an active low signal. Generally, it is pulled high, that is at VCC level. If the master and slave are not talking to each other, when a master needs to communicate with a particular slave, it will pull the clock select line to ground, which notifies the particular receivers that the master wants to send the data. SPI is a standard protocol. What does that means? Well, unlike UART and I2C communications, there is no specific bit frame for the SPI communications. So, it becomes easy to send the receiver data. Well, there are the multiple modes in the SPI communications, which gives flexibility to program data in four different clock mode combinations. This depends on the clock polarity and clock phase. This allows the SPI communications to interface with different types of serial devices. Let's check this table. There are four different modes based on which the master and slave can communicate. In first mode, where clock polarity is 0 and clock phase is also 0. In this, there is no delay for the clock pulses. The data is output immediately on the rising edge of SPI clock, and input data is latched on the falling edge of the clock. In second mode, where the clock polarity is 0 and clock phase is 1, the SPI clock start after some delay and data is output one half cycle before the first rising edge of SPI clock. This input data is latched on the rising edge of SPI clock, and later the data is again output on the subsequent falling edges of the clock. Later comes the third mode. The clock polarity is 1 and clock phase is 0. Here the clock starts without delay, but it starts from the high states and data is output on the falling edge of this clock signal, and the data is latched on the rising edge. In last mode, the clock polarity is 1 and clock phase is also 1. The SPI clock starts after some delay and data is output one half cycle before the first falling edge of the SPI clock, and input data is latched on the falling edge of the SPI clock. But later the data is output on the subsequent rising edges instead of falling edge of the clock. So these were the modes of SPI communications. Well, that's the basic of SPI communications. Now, we will see the SPI communications data transmission, how it will be worked. We look into how does the data transfer from master and slave devices in the SPI communications protocol. To start with, that we need to see the hardware and internal blocks of master and slaves. There are the shift registers in both masters and slave devices. The slave and master are connected in such a way that the two shift registers form an Intel device circular buffer. Now, these shift registers operating serially in serial out mode. The output of the master shift register is connected to the slave shift register, and the output of the slave shift register is connected to the input of the master shift register. This makes the connections which operate in a loop. The link which is connecting master shift register to input of the slave shift register is mostly line, and the link which is connecting output of the slave shift register to the input of the master shift register is meso line. Well, SPI is a synchronizations communications protocol, so there will be a clock signal for both master and slave for synchronizations. And master generates this clock to get the control of the communications. For now, let's ignore the chip select line. Let's see how data is transferred from master to slave. Let's imagine the data in the master shift register is R7 to R0 and data in slave shift register is D7 to D0, where
Someone asked me this question actually, how that is data in your batch or any other batch. I don't know how, like a master, it will be transfer the data in this level. In design, I was explaining the design. Okay, so like this, it will be transferred.
D7 and R7 are the MSB of the data, and R0 and D0 are the LSB of the data. Means most significant bit and last significant bit. Master initiates the communications by generating the clock pulse. As soon as clock pulse starts, shift registers from both devices. Shift the first bit, that is the master shift 0 and slave shift D0 to the right. Well, the master and slaves are connected in ring, so the ejected R0 bit gets stored in the MSB position of slave shift registers, and these robots get stored in the MSB's positions. This is how the first bit travels from master to slave and from slave to master at the same time. When the master generates the next clock pulse, the preceding bits get shifted from the master to slave and slave to master. And that's how each bit travels over MOSI and MISO line in the SPI communication. Protocol. Well, in this protocol, each slave needs a dedicated chip select line, but this can be eliminated by using daisy chain method. So just one chip select line is connected to all the
Here you
SPI
can check,
slaves,
okay, like how
and
like a
this
slave
daisy
1, 2,
chain
and 3 will work.
configurations is little bit different. The mostly line of the master is connected to the MOSI of the first slave. The meso line of the first slave is connected to the MOSI of the second slave. Again, the meso line of the second slave is connected to the MOSI of the third slave. And finally, the meso line of the third slave is connected to the meso of the SPI master. So these connections from a daisy chain architectures of the shift registers present in each device, and eventually this eliminates the number of pins which are needed for slave selection. Now let's see how data is transferred from master to all slaves. For that, the master will send the data to all the devices. For example, we need to send these data packets to the slaves with name slaves 2 and slave 3. Let's call this
Like D1, D2,
8-bit
3, D3
data
will transfer, okay,
as
like a previous
D1,
data.
D2 and D3. Now we want to send D1 data to slave 1, D2 data to slave 2 and D3 data to slave 3. To do so, initially master needs to start the communication. So well, we will pull the chip select line to low, which is connected to the all slave, and it will start the clock signal. First, we will send DT data to the first slave in 8 clock pulses through mostly line. As soon as this D3 data is stored in the first slave, master sends D2 data in next 8 log pulses through same line. But the shift registers of slave 1 already has DT data. So in this clock signal itself, the slave 1 will send D3 data to slave 2 through meso line of the slave 1. Later, in next 8 clock pulses, the master will send D1 data to slave 1 simultaneously. Slave 1 will send to D2 will to slave 2, and slave 2 will send D3 data to slave 3, and finally the slave 3 will send the response of the data transmissions to the master by using meso line, and that's how data is transferred from different slaves using daisy chain configuration. Well, that's all about the easy part of the SPI communications protocol. Now we will see the advantage and disadvantage of this SPI communications with very interesting analogies. Now we'll
Okay,
see
now here only a few things, this one, because I want to explain you what is the pull-up resistor. Okay, so here only you can see.
low power consumptions compared to an I2C communications protocol.
I told you you need to
because there are
check only
no need
internal thing,
of
okay?
pull-up
Like how
resistors
it will
and
work, pull up
SPI
resistor.
uses clock gatings. We know that the I2C communications requires the pull-up resistors to create the 3.3 volt or 5 volt ideal state. If a device needs to talk, it will pull the SDL line of clock line to low and high continuously. To send the data, the value of this pull-up resistor is in kilo ohms. But as we increase the data transmission speed, this value decreases. For example, we need 2 kilo ohms resistors for 400 kbps speeds, and this resistance value decreases further for higher speeds. So, depending on this pull up resistor value, the circuit draws very much current, which eventually results in power loss. But the SPI communication it's much simpler because there are no pull-ups needed. The only power requirement is its consumption. Dynamic power from switching internal transistor and input output lines. SPI uses clock gating. You know, in synchronizations communications, we use clock signals, and these are the great source of power dissipations because of its high frequencies and load, while clock signal do not perform any computational and they are used for synchronization. So these signals are not carrying any information. The gated clock is one of the most important, which can be used the SPI communications protocol to reduce the power dissipations. If a device is not in use, then the clock line, which includes synchronous storage elements such as flip-flop and latch, can be shut down by turning off the clock of the particular device, which eventually saves power. In SPI communications, we can enable a communications device with chip, select which puts other device to remain in sleep mode or power saving mode, whereas in I2C, even though the data packet is not intended for all slaves, all of them need to be awake and allow clock signal to pass each slaves in I2C communications continuously validates if the data packets is more by comparing the addresses transmitted on the bus. This phenomena consumes power dynamically. Now we will see Bluetooth protocol. How does Bluetooth work? Bluetooth is a fascinating technology. For example, when you play music on your wireless headphones, your smartphone transmits around a million ones and zeros to your headphone every second using the Bluetooth. But how are a million or so ones and zeros wirelessly transmitted every single second between your smartphone and your wireless earbuds? In order to answer this question, we are going to explore the engineering behind Bluetooth and the principles of wireless communication. Before we get into the details and specifics of Bluetooth, let's start with an analogy. When you see a traffic light change color, you recognize what that color change means. The traffic light uses a sections of the electromagnetic spectrum or lights to convey information. The green light has a wavelength of around 540 nanometers. Hello.
This is actually no need to watch, okay? This one, no need. Okay, that is if you want to watch, I will send, but I need to complete it this one first. Okay, so now introductions to the Boolean algebra. See, previous you already worked on the analog. This is now the digital, okay? So what will happen now when true 1 and false 0 means true 1 means LED will be turned on, means like whatever these connections are there, it will be turned on, and 0 means that connections are the turn off. That is the logic, and it is the mathematical foundations for the digital logic design. So key concept of the Boolean algebra here, the basic operations, Boolean laws, and the properties and the Boolean expression. You already did the circuit on the easy EDA software, okay? So there, that is actually analog, and digital means you have to select all those types of gate, okay? And you need to do it. So there also a lot of things are there. So introductions to actually what exactly you want to do now. I want to, okay, first listen. See, if like a microcontroller is there, you need to connect like a lot of ICs, otherwise a lot of header piece and also pull up is important. But inside the traces are important. So in that software, you can just type the trace, select the width, select the top layer, bottom layer and anything, and you need to start doing. Okay, that is the basic thing. Whenever you can try, you can understand automatically, okay? Because there is mention ki this track is not allowed to go this top layer. This is not allowed to bottom layer. So you need to change the layers only. There is only I'm asking for the single sided. Just imagine for the double sided and like a multi layer. It is difficult, okay? So here now the basic operation for this operation, maybe you know, using this one, maybe you already solve the problem for the K map. And if you not, just drop the message over here, that PPT also I'll share. Now Boolean laws and the properties, there is the identity law, null law, this one complement A I think ho gaya tha, and introductions to the Boolean algebra, this one. Okay. Now, this is the sum of product and the product of sum, I think already completed. And term and these or, okay, ये वाला हो गया था. Then application in the digital logic design. Now, this is the important for the logic circuit design, K-map and the FSM is the finite state machine. So now look at for this the logic circuit design. What is the rules for the logic circuit design first of all? So designing circuit to perform specific logical functions using the Boolean expressions and the logic gate. Logic gate you already know. Example for like arithmetic circuits, adder and subtractors are there. Multiplexers, the multiplexer, encoder and decoder. These all are the example. That's why I told you that adder and multiplexer relevant thing. Okay, how it will be transfer. Now, K-map generally a visual method for simpling Boolean expressions and helps in the minimize the number of the gates needed for a circuit. You know, whenever you can add that the K-map and all, you need to draw these types of design. Okay, like this, whatever a plus b, okay, आपका जो भी equation है like a bar plus b, okay, plus a dot b, whatever जो भी you got the result, you need to draw this one, okay, here like this, okay, then maybe in between the AND gate and all, okay, so like this you need to draw using that design. हाँ हाँ हाँ, होगी कशिश, एलएमएस में होगी शायद, मैं यहाँ पे भी कर देती हूँ, ओके डोंट वरी. Anyways, we have the time now. I will add, actually last few days, actually my health also not good, I was down with the fever and all, so I need, give me some time, I need to add it, because what will happen, I can understand this course is little bit hectic, means what exactly, see, time period is very less, okay. Second thing is that if properly you have to use like a VLSI, it's fine, but few more student is like a different sessions, I don't know, like different branches, so how they can manage. But VLSI student can manage because I'll sending all from the starting basic semiconductor. And you also let me know ki like this portion it already done in your college or not, because this is the too much theory part actually, and this one you need to do, you need to resolve anyway, and how you can I don't know. But in that the whenever I start in the design part and all, there you need to draw, you should know all those uh syntax, okay, and all those symbol. Yeah, some of theory of done, that's why I don't want to explain in like briefly and all. Okay, so all those important part I written over there. Other student maybe they can search if they want to learn, because I need to start the VLSI design flow also. Okay, so here See, I want to show you one more design, like how exactly you want to do, like end of the day and all. I want to show only analog design. You can do with the digital, and then you can do with the analog plus digital. Let me show there is that in that the Micron company student, lot of companies like Texas and Micron, okay, they already did. I only explain them. So few videos I have. So what exactly you want to do, that is means you can learn lot of things, not only the
Hello,
single
I'm
one.
Priya S from Microchip. I joined
See, look at this one. Okay. Means actually you need to do, this is the microcontroller chip, and this chip where exactly you can connect. Okay, this is all those the pull up resistor are there. Okay, here all of the header files are there. Okay, there are the all track are there. Okay, look at these tracks and everything's are there. Okay, so exactly this is I told you na, easy EDA, like open source software, but few companies like, see, Micron is using to the LTM, uh, which company name, they are using the OrCAD Cadence. Okay, so whatever the score industries and the VLSI designs companies are there, they are using the different software. So few company allows for the Cadence, few company allow for the Metagraphic, few it's allow for the LTM. So you need to, that's why I'm telling you, you just try, use only open source software and try it. Okay. After that only you can able to learn design and all those things. Maybe they gave you one schematic design and they will tell you how you can, yes, I will share, how you can draw the circuit. Okay, means this part you need to do maybe in interview. Okay, so you should know because silicon na, VLSI design, so you should focus on the design. This is only analog. Okay, you need to draw the what you call digital and then mix up signal. So there are in that software a lot of A to ADC ICs are there, means analog to digital converter and all. Okay, so look at this one.
Hello, I'm Priya S from Microchip. I joined this course ITM PCB designing to learn
Here, I mean, name also mentioned like a Micron. So Micron company generally, maybe if anyone wants to do ready for the interview and all, just focus on the LTM and digital design and analog.
more about PCB designing. I was trained by Vaishnavi Tiwari ma'am. So first we have this power supply schematic. So for the battery we have a header and a capacitor, and for the power supply we have used LM1117, which is a low dropout voltage regulator. The schematics for this was drawn in the schematic library as shown here, and the footprint for this is like this, and the 3D view of this is as shown. As you can see, we can rotate and see the 3D body has been placed exactly on top of the footprint. So we have this MCU. The MCU which we have used is the STM32F103C8T6. So this is a part of the MCU
एक
and the
second,
part
रुको. Actually, these are the pull-up resistor. Okay, it's mandatory to connect with your microchip. Yes, Kashish, I will share. I will share. I will create one WhatsApp. Okay, WhatsApp group, and I will add all of you. I know this is really a little bit tough for the beginners and all. So I'll share. Okay, don't worry about it.
the MCU which we have used is the
This is also one
STM32F103C8T6.
more, the most of them, this is also one microcontroller. Maximum companies are using this IC. Okay, like few students are working on these Arduino relevant, but few it will be work, they will work on the STM32. Okay, and these all those we need to add.
So this is a part of
That the student, these different uh, project I explained. So few already done and they sent me the video. Okay. And they already joined there, but they have few doubts. So that's why they join, and within a 25 days, they can learn this many things. Okay. Only 25 hours, not like a 9:30 to 5:30 and all.
the MCU, and the part B is connected to the power supply. We have MCU crystal which has 8 megahertz crystal and also 32 megahertz crystal, and we have a reset circuit. a boot circuit, which two of the boot circuit, one is a 3-pin header and one is a 4-pin header.
So
And
that's why you should know 3-pin header, 4-pin header, microcontroller, optocoupler, 7805, everything. Okay, that's why start learning with the EZDA.
we have general purpose input and output pins, which is connected to the resistor circuit, and also bypass capacitor, which is connected to the power supply, that is 3.3 volts and ground. And the PCB design for this is shown here. The power supply, which was drawn in the first schematic, is as shown. So we have, this is the LM1117, and these are the other components mounted on it, and we have MCU over here, and the 8 megahertz crystal is placed here, and the 32 megahertz crystal is placed here. This is the reset circuit, and we have boot circuit over here. We have 14 pin header, and here is the 16 pin header connected to the resistor circuit, which is connected to the MCU. So this is a 2D view of the PCB, and the 3D view is as shown. So as you can see, few components are mounted over here and on the top layer, that is, and few other components are mounted on the bottom layer. As you can see, these are the bottom layer components. So at last we have CAM static document. This is
This
generated
is
by
actually the company's laptop, okay, they are providing, and this is the Micron setting. Okay, so that's why here it's already, now it's not clear, but here is written that the Micron companies, okay. So thermo feature, they will ask generally the amplifier, comparator relevant question means most of the amplifier. Micron, they will ask like analog theory, like this PCB design, okay, analog and digital both. And then one more, the Texas, they will ask, no, not Texas. We'll see. Texas generally focus on these C++ and sensors, okay? Interfacing with the board sensor and all. But generally, VLSI student, let me check with the previous student, okay, whoever did the interview. Actually, they called me and they informed me. Like after finish the interview, so they want to explain me what exactly they asked and all, okay. So because that knowledge, I'll it's means मुझे help होता है what exactly they are asking and I want to tell you means you are also ready for that. Okay. So now you want this one. Let me share. Okay, number and name I didn't mention. Okay, so just I'll just written like this, but I will share one more time. Okay, that all PPTs. Just a minute. Try again. Wait a minute. Stop sharing. I need to stop first that. एक सेकंड ना मैं zoom करती हूँ. I will create group. Okay. This one you want na first one. Here like introduction. Okay. Simulation, verification, design, different type of IC. Okay. There again, I need to add over here verification, simulation, EDA. I need to add few more things, but it's okay. You can at least just check what is inside and all. Okay, digital IC, analog, mixed signals, power management, FPGA. FPGA also, CMOS also important, Verilog, CMOS, FPGA. Okay, but before starting this one, you should know all these things. Okay. Okay, this says I want to share with you right now. Open is this G. Guys, what you have to do, just create one folder, okay? And add all those PPT there. Okay, all those PPT over there. Okay, wait. This is not, you know. एक second रुक जाओ. Any questions if you want to ask? Stop sharing first. Let me save. Guys, आपको अगर कुछ क्वेश्चन पूछना होगा तो पूछो. You can ask me the question. Don't be shy, okay? I know you have the lot of doubt, but you are not asking. Clear करो आपके doubts, okay? See, don't sit silently. I told you, you all are the engineering student, okay? So why you are sitting silently? आपको कुछ दिनों में इंटरव्यू के लिए रेडी होना है, okay? One PPT saying just Do it fast. This is not sharing the number and all, okay? You just save like this only. Create one folder and save. Again, one more time, I will share this one. You don't have any question. All doubts are clear. Now, guys,
हेलो
हाँ बोलो.
मैम एक्चुअली मेरे को पुल अप रजिस्टर का जो आपने बताया वो वीडियो में समझ में नहीं आया था।
हाँ
हम्म।
बोलो.
उसमें हम पुल अप रजिस्टर मतलब वो कैसे वर्क कर रहा है और वो हम उसे एसपीआई में क्यों वर्क नहीं कर रहा ये चीज समझ में नहीं आई। पर रिपीट
Actually,
कर देंगे।
simple है. आपको when you, if without that resistor, it won't be possible. See, what will happen internally जब current flow होता है ना, तो current 5 volt होता है. See, I am explaining in English. What will happen whenever it will transfer the current like microchip to any other sensor? So what will happen? It will be like 5 volt, 6 volt, something is there. But just imagine your IC. Your IC voltage is the 3.3 volt, correct? So 3.3 volt, it can't absorb like a 5 volt supply. So for that, internally we need to add the pull-up resistor. Okay, so all because see, we don't have the idea whenever you can make a chip, you already made means आपने बना तो लिया, but अगर कोई external any other user they want to um, connect any 5 volts, so what will happen? That's why pull up resistor and 7805s are important because it will oppose the current. What exactly resistor are doing? Resistor are oppose the current. Okay, that's why I'm telling you few semiconductor knowledge is required for this learning. Okay, again any doubt? So internally, actually, what I'll do now, you just watch first video, okay? Then you can understand. Read this PPT, check it everything. Again, I will share and not like whatever exactly in your course and all because relevant PPT also I want to share with you. Because see, like adder you can understand, but subtractor PPT is not there. That portion is not there. So how you can understand that one? I know that thing. Okay, student maybe they have the issue. So in that scenario, what I'll do, I will share the PPT with this only, like adder, subtractor, multiplexer, marks, flip flop and all. But कुछ तो आपको कॉलेज में हो गया होगा. So please guys, at least वो portion मुझे छोड़ने के लिए बोल दो. Otherwise you can watch the PPT, otherwise my video. That's it. Because we don't have this much of time, na? That's why. Okay, I shared this one introduction done, MOSFET done, VLSI design done. Overflow, I will explain the later. And that video actually na it's 6 to 7 GB, so I need to cut. Okay, otherwise I can't. And even I'll upload in my channel, it will take time. So give me some time, I will upload it. Okay. Shall I have the another session? Guys, okay, and please speak. Okay, speak something. Hindi language also fine, Marathi language also fine, English language also fine. Okay, but speak something. Don't sit silently. Else you can drop the message in the chat box. Okay. See, you need to clear your doubt. That's it. मुझे आप लोगों को इंटरव्यू के लिए रेडी करना है. That's it. And if you are the first year, second year student, so just learn. I have the lot of material and you need to learn. That's it. Okay, guys. Chalo. Can I leave now? I'm leaving. Good night, all.